the manufacturing process of the Yadea TTFAR motor. Inside Yadea's automated assembly workshop, the birth of every high-energy motor undergoes surgical precision and craftsmanship, especially in the stator wiring stage. The messy reddish-brown copper wires must be straightened by hand and fitted snugly against the stator edge. This prevents the motor from short-circuiting. During high-load operation, workers require immense patience to pull all copper wires tightly inward from the bottom and secure them. The warmth of mechanical manufacturing is often reflected in these manual details. After trimming, the worker flips the iron core for a detailed initial visual self-inspection. Next is tin soldering, dipping the copper wire joints into a molten solder bath. This prevents copper wire oxidation and significantly boosts motor conductivity. Each joint must be evenly coated with solder with no gaps whatsoever, because a slight oversight will cause poor contact during later motor use. On the high-speed rotating test bench, the soldered stator displays the symmetrical beauty of industrial manufacturing. This is not just a showcase of craftsmanship, but preparation for the next step. To ensure safety, a female worker slides insulating sleeves onto the copper wires. This serves as an important physical barrier between high-voltage power and signal wires. Sleeve installation relies entirely on manual touch, with workers moving deftly and accurately, without missing a single pin. This is also a core detail ensuring the motor withstands stress. Next is the meticulous trimming of wire ends, using diagonal pliers to cut off excess UV, insulating tubing, and copper wire. The whole movement is clean and crisp, without any dragging. This effectively prevents wire ends from being squeezed or worn out inside the narrow housing. During subsequent assembly, semi-finished products must undergo rigorous inspection before final assembly. Besides using their naked eyes to check for appearance defects, inspectors also use a red brush to clean off tiny metal shavings adhering to the surface. Afterward, they sign their names solemnly on the log sheet, which represents a quality guarantee and absolute responsibility for the subsequent processes. The stator is sent to the tester, and as the pneumatic protective cover drops, multiple electrical performance tests are completed automatically in an instant. The screen lights up with a green pass sign, and only stators that pass the test get the ticket to the next process. Amid the roar of heavy hydraulic presses, the metal shaft is precisely pressed into the stator center hole. With tons of pressure, the mating tolerance of the two reaches the micron level. Workers must carefully install the ear guard component plate, applying local spot glue with transparent adhesive to secure it. Next is stringing the wires, where black cables must pass through the stator central shaft hole, serving as the lifeline for transmitting power and control signals. Soldering the hall wires is a highly difficult precision job, requiring blue, green, and yellow wires to be manually and precisely soldered onto the circuit board, without the slightest cold solder joint. The three-phase coarse wires are handled by a fully automatic welding machine, where high-frequency pulse welding withstands high currents during motor operation. The gluing stage should not be underestimated, as a pneumatic glue gun evenly smears a circle of sealant on the center elbow hole to block the ingress of moisture. Female workers use high-toughness nylon cable ties to forcefully tighten all outgoing cables, then neatly clip them with pliers to prevent wear during operation. For the black rotor with extremely strong magnetism, workers must carefully wipe it with a lint-free cloth to thoroughly remove any iron filings and dust attracted by the magnetic force. A gluing machine dispenses adhesive along the edge of the rotating brake cover, creating a crucial barrier against moisture and dust. Then, heavy pneumatic cylinders forcefully press and combine the cover plate with the rotor, so they tightly interlock. At this point, external assembly is complete, and high-precision laser scanners perform seamless welding on the wheel track gaps. Next, workers align the stator wound with red copper coils. And insert it into the wheel track's strong magnetic center. Under the strong magnetic attraction, an automatic pressing machine must be used to prevent positioning deviations. The orange output wire is snapped into the black insulating rubber sleeve to prevent the cable from being cut by the metal shell. Finally, the large diameter metal end cover is placed on the side of the wheel track and firmly pressed into place. The end cover provides strong structural support for the central axis. The pneumatic tightening head drops rapidly and high torque tightens the screws around the end cover all at once. It is sent back to the hydraulic press bed for final pressing and calibration of the central axis, ensuring the rotating shaft core is in a perfect position. The motor is instantly powered on to spin at high speed. To pass the rigorous pre-factory exam, the computer system performs real-time judgments on various performance parameters, and all green lights indicate a pass. After passing inspection, the golden yellow angled air valve is installed, which is the core channel for inflating vacuum tires during daily riding later on. In the final packaging area, workers need to put washers and nuts onto the threads and quickly tighten them using a heavy-duty pneumatic wrench to prevent severe accidents caused by axial loosening of the motor on bumpy roads over time. The powerful hub hearts are neatly arranged now, and it is they that make electric vehicles more energy efficient and take you further.